A very good evening to you all and a very happy Tuesday. So, how's everybody doing? And I know it's really hot out there in Kolkata. So, if you're joining us from Kolkata, so definitely don't forget to have coolers beside you because it's definitely so hot right now here. And so, what's up, everybody? So, has everyone joined? I would like to see a lovely chat coming in from the comment section. So I would like to know how many have you had already registered for the hackathon and how many are likely to were waiting for the approval. So if you're not aware about today's event, so this is from the team Hack for Bengal. So Hack for Bengal has organized today's event. So Hack for Bengal is an 36-hour long hackathon. It is an offline hackathon. The dates and the venue is yet to be announced. Yes, and that was all about it. So, have Hack for Bengal is also a student-run community. We organize different events. We organize events on Web3, Web2, and etc. and all. So, what are you waiting for? Make sure to join us in all the events that we stream. And hi, Shreyas. Hello,
Hey, hi,
Shreyas.
hi everyone.
Hi. Hi. So, Shreyas, would you like to share some few things about Hyperlane community?
Yeah, so Hyperlane community, it's a very robust community of devs, content creators, everyone. Okay, but Hyperlane, since it being a much of a technical kind of stuff on the internet and on the blockchain space, so the community mainly consists of developers for now. So yeah, and then you would get any sort of help on any like whatever you're developing, or not just Hyperlane, anything it might be, because that's what the community is built for. Yeah, that's a small
Okay,
sneak peek
that's
into
really
what.
an awesome. Okay. So as Shreyas mentioned about Hyperlane, so we would like to inform that today Hack for Bengal is here with you for another yet awesome event, which is about introduction to Hyperlane and a demo about messaging and API. So we have today with us Mr. Shreyas Padmakiran, who is a developer at Chidex, Devrel at Hyperlane India. So please put a huge round of applause for him and let's start with the event. Hey, Shreyas,
Awesome.
please take
So
the
can
lead.
I share my screen?
You can just share your screen. No issues.
Yeah. So guys, is my screen visible now? I just want a quick yes from anyone.
Yes, it's visible right now. Yes.
Okay. Awesome. So what I'll do is, I'll just start with a small a small PPT on what Hyperlane is, and then we'll go to Remix. I have a demo smart contract that anybody can, use it to implement Hyperlane into their own project, and we'll also deploy those contracts and send a message from one chain to other chain. All right. So Hyperlane, as you guys can see, it's called the interchain highway. So interchain in the sense you can have assets, or you could talk. You could make two different blockchains talk to each other, and you can have your you if you're building a application, you can have your users on different chains, all the data aggregated into one place. Okay. So Hyperlane, how it is different from anything that exists. First thing is, anybody could deploy their own Hyperlane. I mean, you itself can deploy the Hyperlane onto two different chains, any chains that like as of that matter. And then secondly, it has modular interoperability, which means you can have only specific set of things for your contracts, or whenever you're importing any Hyperlane SDKs, or if you're deploying Hyperlane itself onto two different chains, you can have your own rules and regulations for it. Okay. So that's like two quick things of what Hyperlane is. Like, let's go. So this is what I meant by the modular interoperability. So you could actually create a network between different blockchains. You can have your smart contracts deployed onto any blockchain, and now you can let those smart contracts talk to different chains. Before I tell you why we tell about we want to talk to different chains and all those, The main reason that we want to different change is because users do not have their assets, I mean crypto or NFTs, whatever it might be, and their data on just one particular chain. All right. Now, as a developer, while you're building an application, you would want all of the data with you, all right, or at least it will actually decrease the user. I mean, it'll increase the user experience elevation, but it decreases the user difficulty in navigation. Because with respect to Web3 applications, navigation across the application is a very tough task. Like you guys might have seen, like you go to an application, they say connect wallet, and there are so many different colors at the same time, so many what do you tell, like new words, like I would have never heard of those words when I go to new websites, right? So when it's like all of this, people are like are looking into their own interests of different chains. Now Hyperlane, what it does, it'll have all of your assets under one place. Okay, so I actually went a bit too deep onto what it is, and then yeah, let's go to key features. I want to actually spend more time on the demo. All right. So in consensus, this is actually one of the most interesting thing about what Hyperlane is built on, at least to me, because there are other competitors who already have this interchain highway. I mean, uh, they do facilitate data transfer between chains, but this sovereign consensus is what sets Hyperlane completely apart. Okay, I'll give you a small example so that you'll understand. Say there are two different chains. Let's take Ethereum and Polygon. Like I hope these are like very common chains. All right. So let's say there is Ethereum and Polygon. Now you have you have deployed smart contracts on both the chains and you have implemented Hyperlane to it. Now say it's just one message going from this the Ethereum smart contract to Polygon smart contract. That's all. Just a message. That time the security need not be too high. Okay, because what could you get hacked on max to max? A string, right? But when tokens are involved, like you're sending tokens from Ethereum to your Polygon chain, that time you might get hacked. Okay, that's where usually bridges get hacked. Okay, so what we do is, we don't use a complete bridge, but on the back end we do use USDC's like network. Okay, leave that. So what Sovereign Consensus does is, now say when you want to transfer assets between two different chains, like very critical assets like crypto or NFTs, that time you can define more security onto these smart contracts using our Hyperlane SDKs. So that time what happens, the chance of you losing those assets is very less. Okay. So this aspect of giving the user or the developer their own choice of how much security to be enabled, how much security to not be enabled, because security comes at a cost. All right. Say if you're implementing a very robust security onto both the smart contracts, while maybe you're transferring tokens and all that time, there is more computation involved, so more cost while you're transacting something between blockchains. So now say you don't want to pay so high gas cost just for transferring a message, right? So that's what I meant by like you could deploy your own consensus onto different chains, and you can set your own like, I mean, you can deploy your own smart contracts, set their own consensus, and then you can take care of how much gas cost you want to pay, and then set decide on what consensus type you want to set. And then permissionless deployment, I told you, anybody can deploy Hyperlane, like just right from your systems, because there is a robust documentation for that. And verify fraud proofs and permissionless slashing. So about this, I'll tell you when I actually come to the Hyperlane's architecture. That's when you might understand. So there are a few features, like one is interchain account. So what Hyperlane does is, with respect to interchain accounts, say you have an account on Ethereum chain, but you want to view something on the Polygon chain. That time Hyperlane deploys a proxy account onto the Polygon chain, and it'll let you redirect and check data there. And next one is say interchain queries. Okay, that's what when you want to watch a few, I mean, view, like do some view functions onto different chains. That time you can use interchain queries. Okay, so all of this are like the application part and what Hyperlane is mainly based on. Now I'll just go to like one slide. After that, I'm going to take you to the demo. Because why I'm telling you this slide is because this way you understand how Hyperlane works, and in turn you'll understand what we are actually doing on the contract and why we are doing it. All right. So Hyperlane's architecture, right? So I'll give you an example so that you will understand better. Okay. So say there is a chain A, let's call this Ethereum, and then chain B, call it Polygon. Now, when you're actually sending a message from one contract to other contract, it's just like sending from uh, one one part of the country to other part of the country. How do we do it? Post boxes, right? So what Hyperlane does is it has something called mailbox on all the chains. Now, what you do as a contract, you will send a message to the mailbox, and once it is in the mailbox, the validators will actually check about what's happening, like what message came or what was the newest transaction that happened to the mailbox. They'll validate it, and again, the validation depends on the consensus that the contract has had. You can actually set it like, I want four of them to sign it, or I want eight of them to sign it, I just want one of them to sign it. You can set whatever you want. Okay. So based on that, the validators will verify it, and they'll give the signatures. Okay, the signatures of the validators is given to the relayer. Now, relayer, what it does, it'll go to chain B, it'll give the mailbox. Over here also again there'll be validators. They will recheck those transactions, and then what happens is they will check even whether sovereign consensus is actually verified. Like if there are four people who actually paid it, I mean signed it, or is it like one person who signed it and he sent it across the layer? All of that is checked. If the consensus is correct, then only it will go to the receiving contract. So before your message comes to this contract from your the Ethereum contract, it's gonna go through all of this, and this is the main architecture of what Hyperlane is built on. And one more thing, you see this watchtower here, right? So what this watchtower does is, say when there is actually some fraud, like the validators colluded and they did some fraud. That time, Watchtower will actually re-verify those transactions, and it will remove the validators from the Hyperlane network, as well as it will take away their stake. So that's what I meant by fraud proof and permissionless slashing. All right, guys. So this I just wanted to give you a brief intro on how Hyperlane works and what Hyperlane is. Let's go to the demo. Yeah, so I actually have a contract ready. I will share it with the Hack4Bengal team. Maybe they might, send it to you across these resources. Just a second, I'll just reload. In the meantime, I'll actually explain you how to, structure your application or contract in order to implement Hyperlane's messaging API. Okay. So firstly, we have a router. We have a SDK called Router SDK. So import the router file. I hope it opens. I can show you. Yeah, awesome. Oh shit. Mm, just a second. Okay, fine. Check it. So yeah, you have to import our router SDK, and after importing the router SDK, there are a few okay, you have to deploy the contract, but there's a catch. So remember I told you about this Hyperlane architecture, right? So over here, what's happening is whenever you're sending your contract has to send it to the mailbox, right? It has to call the mailbox on the blockchain. Now, how does it call? So mailbox has a function called process. Okay. So when you're sending a contract, that process function is triggered by the router SDK. Okay. So when that happens, only the mailbox will be able to receive your message. The next thing is, whenever you are actually trying to receive a message on what particular on the secondary chain, the secondary chain mailbox also has to call a function in your smart contract. So you need to have a function on the smart contract called handle. Only if you have that, only then your the secondary chain mailbox will be able to call your receiving contract. Otherwise, it's not going to happen. Cool. So that was just something that you need to know before I could deep dive into the other stuff. Awesome. So yeah, you have to import your contract and then deploy the contract with a few specific functions. I told you, right? Process and handle. The thing is, process is actually handled by the router SDK, but your handle function has to be written by you on your smart contract. All right. So now, after deploying, you need to set the router address as chain B address. We'll do it. We'll do all of that. And I'll just give you a brief hint on how we'll be going forward. Okay. So yeah, you have to set the router address as this other contract. And then you have to call your function, which has the dispatch with gas method. Oh, sorry. Yeah. And then you need to also send in some gas amount to it as value, then wait for some time. Then Hyperlane will actually deliver to your other contract on the other chain only if you have the handle function in it. Okay, so other contract will also be the same. It will have its router file, it will have its contract deployed, as well as it will have its router address set to chain A ka router address, I mean the contract address. Let's do it. So this is a dummy contract. I'll be sharing this dummy contract. Okay. Okay, let's save. Yeah, sure. So initially it's all right. Like I'm importing the router file here. I mean the router from the router SDK. I'm implementing it to my contract, and then I'm setting a mailbox because this contract has to know which mailbox does it call to. And see, again, mailbox are nothing but they're just smart contracts at the end of the day. And then we need a interchain gas pay master. What interchain gas pay master is nothing but for all of these transactions to happen inside the Hyperlane network, you have to pay the gas. So you need to also know which contract to send that gas to. So this is the interchain gas pay master. So you have to set these two usually. You will actually get it in the Hyperlane docs. And then so what I'll be doing is I'll be just calling a hello world function. It'll do the dispatch with gas method that actually mentioned over here. So the dispatch with gas takes in a destination domain or the chain which it has to send the message to, and then you can send in a message, and then I'm sending some gas amount and then some value. So the gas amount will be usually used for your uh, the core blockchain gas amount, but the message dot value it will be used for the Hyperlane's internal callings and state changes. Now that's one function I told you about. Now I also have the handle function. So the handle function will be called by the mailbox. Okay. And then it will be called by from which chain it came and who is the sender and what is the message. So in order to show you guys that it actually works and for my debugging as well. So I am actually incrementing a single variable to +1 when I send a message, and whenever I receive a message as well, I'm doing a variable to +1. Okay, awesome. So let's actually deploy it. We'll do it on Mumbai to let's see where I have funds. Yeah, Mumbai to I guess Sepolia. Let's try Silo. Awesome. So we'll be doing it between Mumbai testnet and Alpha Jores testnet. Okay, Alpha Jores testnet of Silo. So before I actually put in my mailbox, let me check my contract addresses. So over here, you'll actually find all of the mailbox address that are deployed by the Hyperlane team. I mean, I told you, right? Even you also can deploy your own Hyperlane, but this is just like already those people have done it, and they uploaded these. So we'll be actually deploying from Alpha Jores, I mean, communicating between Alpha Jores and Mumbai. Okay. So now what I told you, initially you have to set the address of your mailbox. So I'm in Mumbai, so I have to set the Mumbai mailbox ka address. And then default, okay, the interchange gas pay master also of Mumbai because I'm on the Mumbai network. Cool, let's go. Let's just wait until we have our transaction mined. Yeah, it's done. So whenever I want to debug things, I just call the owner function. Yeah, it's me. So we have our Hello World contract onto the Mumbai testnet. Now let's go to Alpha Joris testnet and we'll deploy there as well. Awesome. So the mailbox of Alpha Joris is here. Now we gotta search the interchain gas pay master of Alpha Joris. Yeah, it's here. Awesome. So I guess like both the contracts are deployed. One is on Mumbai, the other one is on Alpha Juris. So I just want to, like make sure I am calling the right contracts. So I'll just make a note of them here. This is on Mumbai and this is on Alpha Juris. Awesome. So now what we'll do is, we'll send a message from Mumbai to Alpha Juris. All right. Now, before you do that, right, before you send the message, now we have done, we imported router, we deployed our contract with the dispatch with gas function as well as a handle function. Now, the next step is I have to set the router address of chain B contract address. Now, over here, my chain A is Mumbai, chain B is Alpha Juris, okay? So I'll have to just, set the contract address of Alpha Juris here. But actually, Hyperlane supports a lot of chains, not just EVM chains, but even WASM chains like Near Protocol, Polkadot, and say, which was the other one? Solana. Yeah, Solana. So all of these chains is like Hyperlane supports it, right? And each one of them have their own different name in architecture, right? So Solana has like 32 bytes, but EVM has 16 bytes. So what Hyperlane did was they just wanted to cut short all of that, and then they only put it to 32 bytes so that it will get compatible with any chain. So now, in order to pad these things of Alpha Juris, what I have to just do is I have to start padding zeros here such that it makes it only 32 bytes. But I actually have a function for that. So yeah, so I have a function here. This is a function. So what I will do is I'll just send in an address. It will return me the bytes array of that address. I'm just running it on the VM. Yeah, you see this? That is the padded address, right? And let me go to the domain addresses. So we are actually deploying it on. We are on Mumbai. We are actually telling our Mumbai contract that this is your contract address that you have to talk to on the Alpha Juris chain. So once that is done, yeah, it's done. Awesome. So now what we'll do is we'll do the same thing. Uh, we will actually set the Mumbai contract address as the contract, the router at our this thing in the Alpha Juris chain. And I'll tell you why we do this. It's again because the Alpha Juris chain will can only then be called by the Mumbai contract address. Any other function, any other contract address actually calling any of the internal functions, it won't work. it will not actually respond to them. This is a Mumbai contract address. Okay, padded them to byte 32. Setting it Mumbai 80001 address. So let it just set the router address. We are just waiting for the confirmation. Yeah, so that's done. Now let's go. Let's actually send a message from Mumbai network to Alpha Juris network. I'll just change my MetaMask to Mumbai back again. Yeah. So yeah, send hello world. So the destination domain is what, double four okay, I'll just copy paste. Yeah, so the message, I'm just sending a message like Hyperlane. And then I told you you need to also send some message.value. If you don't send this, it's never gonna work. I'm sending about point 0.1 matic, but the thing is, after everything happens, it sends me back the balance of it. Usually takes less than point 0.1. Oh, just a second. Double four nine seven routers. Okay, I guess there's a small issue. Double four. Oh, there should not be value. Okay, I guess I did not actually set my router address. Let me go back. Let me debug here. Did I do a mistake? Come on, man. Alpha Taurus. Yeah, so let me just query here. Yeah, so yeah, this set we started with 3139. Mumbai must be 3139. Awesome. Let's go back. Yeah, now I guess it has to work. Mumbai. Yeah, again, I'll just check it again. Yeah, it's set now. 329, which is our alpha journey. Awesome. So let's go now. Now let's actually transact a message. But I actually had to send message.value. Told you, right? I'm telling about point 0.1 matic. Yeah. Let's wait. Let's wait now. This is where the magic happens. You'll have your data from your Mumbai chain to Alpha Juris chain. So we actually sent a message. Now I told you like I'm actually incrementing a parameter whenever a message is sent. It's done. Now let me go to my Alpha Juris network and I will try to see if it actually received a message. Not yet. Okay, it's processing. Let's go check up in the Hyperlane Explorer. Yeah, it's delivered from no way, this was before. Okay, let's wait what's happening. I guess is Alpha just network so slow today? Let's wait, guys. Sometimes this is how it happens. 313. Yeah, right. I'm just like looking maybe if I messed up something in the contracts. Yeah, no, I did not. I know. So yeah, the transaction is completed. So I sent a message from Mumbai to Alpha Jores. So now actually, let's see the received. Like, is it plus one? Yeah, it's plus one. Awesome. So we just sent a message from Alpha Jores chain. No, I mean from the Mumbai chain to the Alpha Jores chain. So I hope like you guys try to implement the router SDK, ran implemented the interfaces, which might kind of take a lot of time. And if anybody has any doubts, like I'm up for taking it now. Thanks a lot.
Hey folks, I hope you have enjoyed this session. So I believe Sir is here.
Hey everyone.
Hi.
Oh, it's no issues, Shreyas. So sorry for a little delay. Shreyas had some network issues. So Shreyas, you can just continue.
Yeah, I know. Yeah, I finished finished the demo on how to show them on implementing router SDK, the Hyperlane onto their contracts, and how to send a message from one chain to other chain. Like I was actually open to questions if there are any.
Yeah, so I think we can have the slides coming in right now. Okay, so
Yeah.
these are some of the questions by our audience mentioned in the chat and also earlier in the registration form as well. So, our first question for today is, can I integrate the messaging API into my existing app?
Yeah, you could do it if you have a smart contract that's running on different chains and you want the data aggregated, or you want different chains to talk to each other. Only if you have that requirement, I would tell you to integrate messaging API, and it's just like you just have to add a 2 to 3 functions extra. That's all.
Okay. Are there any limitations on the number of messages or users that can be supported by the messaging app? API, sorry.
No, yeah. So it's not like that. You could actually send messaging messages from one chain to any number of chains. Okay, and there's no limit or cap onto the users or messages that could be sent.
Okay. And are there any additional fees or maybe charges for using the messaging API with Hyperlane?
So it's not like there is any additional fees. You actually have to send some gas amount so that the Hyperlane network will actually process your transaction. That's all. So you will be
Okay,
paying to the network.
okay. Can we customize the messaging API to suit a specific app requirements?
Yeah, like you could, but I'm just interested to know, like, what were the specifications? Because, that time I could actually pinpoint and tell you like the right answer because you told like my app specifications, right?
Okay. Okay, we don't have any specific specifications for now. So maybe I will request the audience to maybe write him on his LinkedIn, or in his social media to ask the question more in detail.
Sure, yeah.
So next question we have, which is about, okay, so the question is pretty tricky. So why Hyperlane and which problem it actually solves?
Okay. So why Hyperlane? So if you are an user, like, if you're actually trying to transact with crypto and all, you will actually come across one thing where if you want to send, say, USDC is nothing but the USD stable on the blockchain. So what USDC does is, now say you want to send USDC from you want to send to me, like, or maybe you're transacting with your friend. Okay, that time what happens? The USDC charge, the gas fee would be higher if you're an Ethereum network. Now what you want to do, you don't want to pay so much of gas fee. Instead, you'll use a bridge, and then you will send that to the Polygon network. After sending it to the Polygon network, you'll actually transact it through the Polygon network to the other guy, because USD value remains the same everywhere. Okay.
Hmm.
So now the user had to do all of this whenever he wants to transact with an application. Okay. But what
Yeah.
Hyperlane does is you can actually select on which network you want to transact this.
Okay,
And
okay.
so the thing is, Hyperlane will be implemented mostly by the applications, right? So the applications which implement can take in the option that, we will, they could implement Hyperlane such that they can take in users from one network and, process transactions on the other network.
Okay, okay. And would you might like to mention about the programming language which are supported by Hyperlane and the like the messaging API? Like what
Yeah.
languages did you use exactly?
It was only Solidity.
Okay, okay.
Yeah. So
So only
for
that.
EVM, Solidity. Yeah, that's all. Like, there's like few functions. That's all you have to import onto your contract, and you could actually use the messaging API.
Okay, okay. So thank you so much, Shreyas. And that's it for the questions for today. And if you guys have any other doubts and you want to mention more, so you can definitely go to Shreyas's social media accounts and definitely tag him or maybe ask him the questions in his DMs. And last, thank you so much, Shreyas, for this awesome event today on Hyperlane. So we can
Thank
have the
you.
next deck. So, guys, so that was all it about today's session. So, Hack for Bengal team is first of all very much thankful to all the audience who were present with us today. And a little bit of disclaimer. So, Hack for Bengal is a 36-hour long in-person hackathon, and the dates and the venue are to be announced pretty soon. And a little disclaimer. So, as I've attended today's session and knew the importance of Hyperlane, so if you are participating in Hack for Bengal and are looking forward towards making a project using Hyperlane, so here's a catch. So, Hyperlane has been sponsoring us as a bronze sponsor, and the prize pool is worth 80K. So, make sure to make best projects out of Hyperlane and get a chance to win 80K.
Yeah, guys. So if you guys, like, need any help, like, I'll be out to help you all.
Yes, Shreyas is there definitely for help. Thank you so much. And little announcements for you all. So, if you are looking for any latest updates or want to know more about the Hack for Bengal, you can definitely visit our website hack4bengal.tech and also know about the latest updates or any about changes or any major announcements. You can definitely go for a Discord. And yes, we had a major announcement yesterday. So, if you have missed the announcement or you are looking forward or you don't have a Discord, like you're not joined a Discord channel, so make sure to join the Discord and check about the latest announcements. Next, we have a new registration coming soon. So, if you are already participating in Hack for Bengal and are looking forward towards the new registration, so make sure to check out the Discord channel and keep for looking forward. And yes, as I mentioned earlier, that if you are lazy like me and don't know about the latest updates, so definitely install the app, the Hack for Bengal app. So, thank you so much for joining us again. And if you liked today's session, so we would like you to definitely scan the feedback form. So, definitely give us a quick feedback about today's session. Thank you, everyone. And thank you so much, Riyas, for the awesome event today as well. Thank you.
Thank you. Thank you a lot.